What if I told you that the universe might not have an end? That everything we know could be just a tiny fraction of something much larger, something we may never be able to reach? The idea of an infinite universe challenges our understanding and forces us to question everything we think we know about space, time, and even ourselves. Since childhood, we are taught that everything has a beginning and an end, but what if the cosmos is a great exception? Science has already given us astonishing answers, but it has also left us with even more disturbing questions. If the universe had a beginning, could it also have an end? If there is a border to the observable universe, what lies beyond it? Could space curve upon itself, bringing us back to our starting point? Or are we floating in a boundless ocean, where every point in space stretches on forever? The answers to these questions could completely change the way we perceive reality. Get ready for a fascinating journey through time and space. We will explore the mysteries of the observable universe, the theories about its expansion, the estimates of its true size, and of course, the big question that no one can answer with certainty. Is the universe truly infinite? But what is the observable universe? Imagine looking up at the sky and realizing that everything we see, galaxies, stars, nebulae, is contained within a cosmic sphere whose radius is limited by light itself. This is the observable universe, the portion of the cosmos that we can detect because its light has had time to reach us since the Big Bang. But here's the intriguing detail. This does not mean that the universe ends there. It only marks the limit of what we can see, as if we were inside a cosmic bubble, constrained by the speed of light and the relentless passage of time. Now, think about what happens when you look at an old photograph. You are seeing a moment that has already passed, right? Observing the universe works in the same way. The light from the most distant galaxies we detect today left them billions of years ago. This means that when we observe these far-off points, we are actually peering into a much younger version of the universe. The fascinating thing is that if we had powerful enough telescopes, we could even see the beginning of everything, the Big Bang, like a cosmic movie playing in reverse. And here arises an inevitable question. If we can only see up to a certain point, could there be much more beyond what we can detect? Is there a real limit, or just a temporary boundary that science may one day overcome? The observable universe is only the tip of the iceberg, and understanding its vastness leads us directly to the next inevitable question. What is the true size of this cosmic spectacle? And what about the size of the visible universe? If the idea of the observable universe as a cosmic bubble already seems overwhelming, wait until you discover its actual dimensions. The radius of this immense sphere is 46.5 billion light years, meaning that the oldest light we detect today traveled all that time to reach us. This results in a diameter of 93 billion light years, a scale so absurd that even the largest numbers we know seem like child's play. And the most impressive part? This vastness doesn't represent the entire universe, but only the portion we can access with our current technology. Now, try to visualize this with a more tangible analogy. Imagine you are in an infinite desert, but your vision is limited by the reach of a flashlight. You know there is more beyond what you can see, but you have no way of perceiving it clearly. This is exactly how the observable universe works. What we see is merely a slice of reality, limited not by space itself, but by the time it takes for light to travel to us. But here's the intriguing question. If the universe has an observable size, does that mean it has an absolute limit? Or is there something much larger beyond our cosmic bubble, waiting to be discovered? If space itself is not fixed, what happens when it continues expanding every second? These questions lead us directly to one of the greatest mysteries of modern cosmology, the expansion of the universe. And talking about the expansion of the universe is not simply standing still in space. It is expanding, and it is doing so at an increasingly accelerated rate. If we could mark two fixed points in the cosmos and observe them over billions of years, we would notice that they are moving apart, like dots on a balloon being inflated. This expansion is so intense that some galaxies are receding from us faster than the speed of light. But don't worry, they are not violating the laws of physics. The space between us is expanding, carrying everything along with it. To visualize this, imagine a raisin bread rising in the oven. As the dough expands, the raisins move farther apart. Not because they are moving on their own, but because the bread itself is stretching. In the universe, the raisins represent the galaxies, and the bread represents the fabric of space-time. This explains why the farther away a galaxy is from us, the faster it appears to be moving. Now, the big question, does this expansion have a limit? If the universe is growing at an accelerated pace, will there come a moment when some regions simply disappear from our field of view forever? Is there a point beyond which nothing else can be observed because light will never be able to reach us? The answer lies in the fascinating concept of the cosmic event horizon. Cosmic event horizon. Imagine being on a boat in the middle of the ocean. The horizon looks like a clear-cut boundary, but you know it's not the end of the sea, just a limit of what your eyes can perceive. The universe has something similar, a cosmic event horizon beyond which nothing can ever reach us. The accelerated expansion of space causes certain galaxies to move away so fast that their light will never be able to reach us. It's as if they are permanently escaping from our observable reality. But this raises an even more intriguing question. What if something beyond this limit is sending signals? We would never detect them. For us, those regions of the cosmos simply do not exist. It's like trying to watch a TV channel when the signal doesn't reach your antenna. No matter how powerful your equipment is, some transmissions will always be beyond your grasp. This phenomenon imposes a definitive limit on what we can know, creating a cosmic veil that is impossible to cross, at least according to the laws of physics as we understand them. Now, think about this. With every passing second, parts of the universe are moving further beyond our reach. What will happen in the future? With each passing billion years, more and more galaxies will cross this event horizon and disappear from our sight. That means the visible universe today won't be the same tomorrow. But how far could this loss of visibility go? Could we one day look up at the night sky and see only a handful of stars? But what does the future hold for observing the universe? Today, we have powerful telescopes that allow us to see galaxies billions of light years away. But this won't last forever. The universe continues to expand, and as time passes, more galaxies will cross the cosmic event horizon, disappearing from our view forever. In a distant future, trillions of years from now, an astronomer might look at the sky and see only the galaxies in our local group, a small cluster of systems that includes the Milky Way, Andromeda, and a few smaller dwarf galaxies. Now, imagine a scientist in that future, without distant galaxies to study. They might conclude that the universe consists only of the tiny bubble of matter surrounding them. No evidence of cosmic expansion, no traces of the vastness that once existed. It would be like trying to understand an entire ocean by examining a single drop of water. This means that we are living in a privileged era, where we can still glimpse the immensity of the cosmos. If we want to truly understand the universe, we must take advantage of this moment to gather as much data as possible. But there's an even more unsettling question. If the universe's expansion could one day isolate us from the rest of the cosmos, is it actually infinite? Or are we simply inside a gigantic but finite cosmic structure? This is one of the biggest mysteries in cosmology, and the answers could challenge everything we think we know about reality. Is the universe infinite? This is a question that has puzzled scientists and philosophers for centuries. If the universe is truly infinite, it means it never had a real beginning and will never have a definite end, something difficult for our limit-oriented minds to comprehend. But there's another possibility. It may be gigantic yet finite. The key to this answer lies in the geometry of space. If the universe is flat, as recent observations suggest, the likelihood of it being infinite is extremely high. However, if there is even a slight curvature like a sphere, then it could be finite, though so vast that we could never reach its edge. Now, Imagine a space traveler moving in a straight line forever. If the universe is truly infinite, they will never encounter a boundary. But if it is finite and curved, they might eventually return to their starting point, just like circumnavigating the Earth. This brings up another fascinating question. Does the universe have a physical end, like an invisible wall, or does it simply repeat itself endlessly, like a cosmic mirror? The definitive answer still eludes us, but the evidence suggests that if the universe is finite, it must be absurdly larger than anything we can observe. But how big exactly? To find out, we need to look beyond the observable universe and try to estimate its true size. And what are your thoughts on the total size of the universe? If the observable universe already spans 93 billion light-years in diameter, imagine the true scale of the cosmos. Estimates vary, but some research suggests that the universe could be 250 to 15 million times larger than what we can currently observe. This means that our cosmic bubble is just a tiny fraction of something unimaginably vast. To put it into perspective, it would be like looking at a single drop of water and trying to calculate the size of an entire ocean. The big question here is, why can't we measure its true size? The issue lies in the curvature of space-time. Depending on the geometry of the universe, it could extend infinitely or form a loop, bringing us back to the same point without ever reaching an end. Think of an old video game, where moving off the right side of the screen makes you reappear on the left. If the universe works this way, we could travel forever without encountering a real boundary, just an infinite repetition of cosmic structure. But if the universe is truly so much larger than what we can see, this leads us to another unsettling question. What about the beginning of everything? If the cosmos is gigantic now, was it always as vast at the moment of the Big Bang? Or did its expansion create this immensity from something much smaller? The answer to this could completely reshape our understanding of the origin of time and space. And connecting this to the Big Bang, if the universe is infinite now, then it must have already been infinite at the moment of the Big Bang, just compressed into an incredibly dense state. This challenges the common idea that everything began from a tiny singular point. In reality, the Big Bang wasn't an explosion in space, but rather an expansion of space itself. If the cosmos was already infinite at the start, then it has always existed in this condition, just in a much denser and hotter form. Now, imagine stretching a rubber band. In the past, it was completely contracted, almost like an invisible thread. But as time passed, it expanded, and every point on it moved farther apart. The universe functions in the same way. There was no fixed center where everything began, because the expansion happened everywhere at once. If it was already infinite, then its vastness only became more diluted, but it never had a defined limit. This idea completely reshapes our view of the beginning of time and space. Instead of a single birth moment, the universe may be a continuous process with no real beginning, just different phases of an eternal expansion. But if it never had a limit, could it one day come to an end? Or are we destined to exist in a cosmos that will keep expanding forever? Now that you understand the vastness of the universe and the theories about its possible infinity, a more mind-blowing question emerges. What if we are actually inside something much bigger than we imagine? In the previous video, we explored the idea that our entire universe might be inside a black hole. And if that's true, could the concept of infinity be completely different from what we think? Instead of an endless space, could we actually be trapped inside a closed system, surrounded by an invisible horizon? If space bends and distorts inside black holes, could our universe follow the same rules? If cosmic expansion creates horizons beyond which nothing can be observed, are we already trapped inside something we will never be able to escape? What would happen if we somehow crossed the boundaries of our reality? If these questions blew your mind, then you need to watch the previous video. There, we explore the idea that everything we know might exist inside a giant black hole, and how this could completely change our understanding of space, time, and existence itself. Click now to watch and continue this fascinating journey through the mysteries of the cosmos.